Hello, guys. My friend suggested that I could use a note or something because this is not. I mean, the whiteboard is not that clear, so I'm using this. So let's just dive right in. So this is SAT Math Lecture 4. Okay. So let's just start in. We have a few symbols. Okay. So this is greater than, and this is lesser than. This is greater than or equal to. And this is less than or equal to, and this is equal to. Okay, I guess my handwriting is pretty good in notes, so I just hope. Okay, so let's go to the next page. Variables, okay, fractions, okay. So I'll demonstrate you through a few examples. Okay, let's say x minus 2 is greater than or equal to 2x minus 1, okay? Now what you do is you solve it exactly like a normal equation we solve, okay? So let's say you get it here, right? So plus becomes minus. So x minus 1 in this side, and this side is minus 2. But there's only one different, a few differences of inequalities from equations. So one of it is in equations minus 2 equals x minus 1. Now when you negate it on both sides, 2 equals 1 minus x, the sign doesn't change, the symbol doesn't change, right? But here, so here you negate it, right? This symbol changes, 1 minus x. So this is the highlight. This symbol changes when you negate. It just becomes the exact opposite. If it's something like this, minus 2 is greater than x minus 1 also, it will become 2 is lesser than x minus, 1 minus x. Okay? So let's get x here. So minus becomes plus. So x plus 2 is lesser than or equal to 1. And when it goes here, it again becomes minus. Okay, we use this. So x is lesser than or equal to minus 1. Okay, and if x, let's see another problem. X squared is equal to 2, let's say, okay? So, x squared is lesser than or equal to 2. X squared is more than or equal to 2, okay? These two have different solutions. So x is less than or equal to plus or minus the square root of root 2. And x is greater than or equal to the square root of plus or minus root 2. So here we have a difference in representing it as a set. So here it's less than or equal to, we do it as this. I'll explain you why. You just copy this down. After that I'll explain about sets. Minus infinity. Okay, so this is how you represent it. Let's say you have 1, 2, okay? You have this integral. It means that every number between 1 and 2 works, including 1 and 2. Okay, including 1 and 2. Every number between 1 and 2 works. It doesn't have to be integer. It can be complex or decimal or anything. It must work, okay? And then if this is called a closed set. I'll just write it here. And then you have 1, 2 open set. Here also everything between 1 and 2, even decimal numbers work, but the difference is 1 and 2 won't work. Like these won't be the solution. And if you have the floor brackets 1 and 2, this is I don't know what is okay how to name this. So only 1 and 2 work. Only these two integers work. 1 and 2, nothing else. Only 1 and 2 work as a solution. Okay, so this is how you represent it in the set, and you also have two more symbols to be covered. So this gives you belongs to, and then this gives you there exists. Okay, I guess it's all understood. Okay, so belongs to, and here it's there exists. So you use it something like that. And then this is used for only sets like this. You also have this and this. Okay, you can also have this. So now let's come back to this one. Okay, so if you take a close look at this is minus 2 comma 2, I mean minus root 2 comma root 2, right? So when it's less than or equal to, you only write what is inside the interval. When it's more than greater than or equal to, you only write which doesn't work in the interval. It's like, except for this equal to one. If this equal to is removed, let's say, okay, then this will be open bracket, because root 2 will no longer work. Okay, so this is the point. And here too, if this goes off, these two do no longer work, so it just becomes the open interval. Okay, so let's go to the next one. So okay, let's go to the part of graphing. Now this is so cool that you'll be amazed. Okay, you have greater than or less than. Okay, then it's an open circle. Like, I don't know if you'd be amazed, but I am. I mean, put something in decimals. It'll give you a circle that I mean, the graph is like, oh, sorry. The graph is iconic, you know. Okay, so this is closed circle. This is also almost closed, but not completely closed. Okay, so because only these two won't work in here, it won't work, right? So let me just focus through. Okay, yeah, negative multiplication. Okay, yes. Number. Okay, now this is the easiest concept I'm gonna ever teach you, ever. Okay, so let's take another line. Okay, let's first of all take a line and write 0. That's it. That's all. Okay, and let's mark 1 and 2 and 3. Okay, minus 1, minus 2, minus 3, like this. Now where's root 2? Root 2 is somewhere around this 1.41 and it goes on. Okay, so here there's root 2, and root 2 is positive because it's right to 0. So when you go to the right, it's positive, and when you go to the left, it's negative. Okay, so if you say minus root 2, it's somewhere over here. So and goes on. So this is negative, right? So that's all about number line. Now you can just look at the quadrants. Okay, you're ready to go for quadrants. 1, 2, 1, 2, 1, 2, and then again 1, 2. Here you're gonna do nothing else but put in minus in the left hand side, just as we saw this. And if you draw a vertical number line, something like this becomes minus, 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 like that. This plus and goes on, right? So here just add minus. So we call this one the first quadrant, and this is the second quadrant, and this is the third quadrant, and this is lastly the fourth quadrant. Okay, so now in first quadrant both are positive, both x-axis and y-axis are positive. If it's the second quadrant, y-axis is positive but x-axis will be negative. If you go to the third quadrant, both will be negative. And if you go to the fourth quadrant, x-axis will be positive and y-axis will be negative. Okay, let me give you a point and guess in which quadrant it goes. Let me give you 3 points. Okay, 3 points. 2, -1, -1, 2, 1, 2, -1, -2. Okay, guess where it goes. Here you see x is positive and y is negative. In fourth quadrant, x is positive and y is negative, right? So this goes to the fourth quadrant. Okay? Now look at this. X is negative, y is positive. So it's in the second quadrant. So it's -1.2, right? Y is 2. So somewhere around this. And then this goes to the first quadrant as both are positive, 1, 2. Yeah, makes sense, I guess. So now this both are negative, so this goes to the third quadrant. So it's, oh, I'm doing a mistake. It should be somewhere around here. This 2. The y-axis is -2. I'm sure also. Just take a look at it. Oh, here I gave 2 and -1, so this is correct. Okay. But here it's wrong. Here it must come here because it's -1 coming -2, right? So we also have something called distance formula. Okay, so distance between 2 points is equal to the square root of x2 minus x1 whole squared plus y2 minus y1 whole squared. Okay, so let's say they're asking what will I say? Okay, they're asking distance between origin and 1, 2, let's say. Okay, so origin, first of all, look at this. Origin is nothing but 0, 0. So if you decode it, this is nothing but 0, 0 and 1, 2. Okay, so now take this as x1, y1, x2, y2. Okay, so now if you plug in the formula, you'll get x2 minus x1 whole square is, where's x2? Yeah, it's 1. Okay, 1 plus y2 minus y1 whole square is 4. So that's the square root of 5 units. Okay, so now this is the answer. So now this is how you use the distance formula. You have something called the midpoint formula. They give you a line, okay? This line they give you. I hope you can understand what I'm trying to say. Let's say this is n and this is m. So the ratio of distance of this, okay, this distance is m, okay, and this distance is n. So the ratio of distances is m. I mean from this point, okay, m is to n, and let's say this point is P. So here P equals mx mx1 something mx2 plus nx1 okay, let me just check.